Hi, hello. Good afternoon, one and all. Welcome to the session. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all competitive examinations. Can you confirm about audio and video so that we can move on? If everything is clear, please do let me know so that we can move on. Is this clear? Audio and video. Meanwhile, we'll have a small recap. In the last session, we had a discussion on series and parallel DC circuits. Series and parallel DC circuits. So in this session, we will discuss about AC circuits. Circuit or network, that is fine. So we will discuss with AC excitation. Okay, there is nothing is going to be changed from series from AC circuit to, or sorry, from DC circuit to AC circuit. The only thing which is going to be is you will be having a frequency. So due to that, you will be getting inductive reactance and capacitive reactance. So you treat this inductive reactance as an extra resistance. You treat this capacitive reactance as an extra resistance with negative. So when you add these two, R minus R, you know R1 minus R2. When they are connected in series, when they are connected in parallel, you can write it as R1 into minus R2 divided by R1 minus R2. So like that you can take up. Okay. So nothing is going to be changed. So simple thing is you just treat that inductive reactance as one more resistor and capacitive reactance also with one more resistance with negative value. But remember, J should be included. Okay. So with that you can, if you remember that, if you do like that, you can, that will be very easy. I don't think you are not going to get any problem at all. Okay. So good afternoon once again, good afternoon. Welcome everyone. Madan Kumar, hi, how are you? Kalyani, hi, how are you? Okay, so let's move on. So let us take up some questions. Before moving on to the questions, there's a small introduction about myself. My name is Naveen Golapalli. I have 7+ years of experience in teaching. Most of the times I'll be teaching networks, measurements, machines, and power systems. Okay, all right. So moving on. So this is a question for you. So have a look at this question. For the network in figure, he is asking calculate voltage VC using voltage divider rule. Okay, calculate IS. So VC is here, voltage across the capacitor is asking, and the current delivered by source is asking, IS. Okay, so voltage across capacitance, how do you use? He is saying the directly voltage division rule. Yes, this is a supply voltage which is directly connected across, connected across this R and C. So use voltage division rule. So supply voltage into this capacitive reactance divided by total ohmic value R minus JXC. That's it. And if you wanted to find out this supply current, the current flowing through this branch plus the current flowing through this branch, you will get the total current. Chalo, let's move on. Let's calculate first the voltage division rule. Voltage division rule. So VC. So VC is equals to supply voltage E into this impedance, that is minus JXC divided by total impedance. What is the total impedance? R minus JXC. Or simply E by E, you just look at this one, E by R minus JXC. What does it means? E by R minus JXC. So that comes out as I1, some current. You just take out this as I2. I1 plus I2 is going to be IS. So I1, so the current into this reactance, capacitor reactance, you will get the voltage. All right. So that is the thing. So what is E? E is of 20 at an angle 20 degrees into minus JXC. Minus JXC. Capacitor reactance is 12 ohms. 12 at an angle minus 90. Convert into phasor domain so that it will be easy. Next, R minus JXC. R minus JXC is 5 minus JXC. 5 minus J12. So you have to, gone case. You have to convert 5 minus J2 into R at an angle theta format. Can you tell me what is that? R at an angle theta format. 5 square plus 12 square. 12 square is 144. 5 square is 25. 144 plus 25, it comes out as 169. 144 plus 25. 169. Root of 169 is going to be 13. Okay, so I am rewriting this one. 20 at an angle 20 into 12 at an angle minus 90 divided by 5 minus j12. I am getting it as 169. Root of 169 is going to be 13 at an angle. Tan inverse minus 12 by 5. Minus 12 by 5. So tan inverse of minus that, we are getting it as minus 67.38 degrees. So this is the VC I am getting. So simplify this one. VC is equals to, magnitudes can be multiplied or divided. Of course, if you have A into B, then you can go ahead with AB. A into B divided by C, you just divide. Okay, so 20 into 12, it is going to be 240. 240 divided by 13. 240 divided by 13. So I am getting 18.46. I am getting 18.46. This is 8. This is 8. 18.46. Now look at the phase angle. So here it is 20 and here it is minus 90. So 20 minus 90, it comes out as minus 70. Minus 70 plus 67.38. Minus 70 plus 67.38. You are going to get it as around minus 2.62. So is this a value for everyone? You have got, everybody has got. So how to draw it now? Source voltage, if you take up the phasors, source voltage is having a phase angle of 20 degrees. So let me take up the reference. From the reference, source voltage is at 20 degrees. So this is my source voltage, which magnitude is 20, and the phase angle is 20 degrees. Now, how should be the VC? How should be VC? VC is at an angle of minus 2.62. So minus 2.62. Let me take up minus 2.62 means very, very close now. Very close. So this is VC. So the angle here, it is just minus 2.62. Okay. Of course, the magnitude is 18.46. So VC is going to lag from the reference axis by minus 2.62. Okay. Alright. So this is how it looks like. From the supply voltage, it is going to lag by 22.62. From the supply voltage, if you see from the supply voltage, it is going to lag by, VC is going to lag by 22.62. Okay. So is it clear so far for everyone? Very good. Kalyani, superb. Others also please do respond. Relax, hi. Relax today. Very good name. Good afternoon. Respond, my dear. Is it clear for everybody? So that we can move on to the other one. Calculate IS. So if you want to calculate IS, you need to calculate I1, you need to calculate I2. So let us take up that. So did I mention it as I2? Yeah, I2. I1. I2 is going to be E divided by JXL. E is 20 at an angle 20 degrees. XL is 8 at an angle 90 degrees. So 20 by 8. 20 by 8, how much you are going to get? I'm going to get it as 2.5. 2.5 at an angle minus 70 degrees. So from the reference axis, you can take up minus 70 degrees. Okay. From the reference axis, you can take up minus 70 degrees. This is reference. So maybe here I am going to draw. So this is I2. So magnitude is very small. So let us take up that magnitude, small magnitude. There is I2. From the reference, it is 70 degrees. From the supply voltage, definitely it has to be 90 degrees, right? Current flowing through the inductor definitely lags by 90 degrees. If you see the supply voltage, where is the supply voltage? The supply voltage was here. E. From reference, it is of 20 degrees. Now you see the phase angle between voltage and this current. How much it is going to be? 90 degrees now. Because current flowing through inductor always lag by 90 degrees. By 90 degrees. See, from 70 and 20 you will get 90 degrees. Okay. Let's see now. Let's see I1. Let's see I1. So how do you calculate I1? How do you calculate I1? Just now we have seen already. That is I1 will be now 20 at an angle 20 degrees divided by this 5 square and 12 square. We have got it as 13. 13 at an angle, how much we have got? 13 at an angle minus 67.38. Minus 67.38. So 20 divided by 13. 20 divided by 13. I am getting around 1.538 at an angle. At an angle 20 plus 67. So it will be 87.38. From the reference, it will be 87.38. So I1 will be off. I1 will be off. From the reference, it will be 87.38. So if I take up from the reference, it will be 90 degrees. Or it is from the reference, it will be 87.38. Very close. Very close. But not on 90 degrees. It is very close. So let me take up this as very close. So this is my I1 and from the reference it is 87.38. Okay, so that is the current. So I1 plus I2 you can add up. I1 plus I2 you can take up. You can get IS value. Right. So you see here, well, there is one more point I wanted to say. If I1 current is flowing through the capacitor, the voltage across the capacitor definitely lags the I1 or not? Voltage across a capacitor definitely lags the current by 90 degrees. Let us see. VC is lagging current or not? Let's see. So this is the current which is flowing through the capacitor. I1 is the current which is flowing through capacitor. Where was VC? We have got VC here. We have got VC here. 2.62 degrees lagging with respect to reference. So let me draw 2.62. So this is VC. You add this 2.62. 2.62. Now from VC, if you take up from VC to I1, how much it is? 90 degrees. 87.38 plus 2.62. 87.38 plus 2.62. You are going to get 90 degrees. So IC and capacitor current and VC are displaced by 90 degrees or not? So that is everybody. Is this clear for everyone? Phasors are very, very, very important, especially for electrical people. Is it clear for everyone? Now you see the resultant current. So resultant current IS is equals to I1 plus I2. I1 is 1.53 at an angle 87.38 plus I2 is equals to 2.5 at an angle minus 70 degrees. So how do you do this one? There is only one option, that is you convert into rectangular format. That is r cos theta plus j r sin theta. In that way only you can do it. Otherwise there is no other chance. So convert into r cos theta plus j r sin theta. It is like 1.53 into cos 87.38 plus j 1.53 into sine 87.38. Okay, this is one thing. And for this one is plus 2.5 cos of minus 70 plus j 2.5 sine of minus 70. So here you will get one term, that is a plus jb format or a minus jb format. Here also you will get a plus jb or a minus jb. Something. You take up a plus jb or add real terms, add imaginary terms. You will get end of the day x plus iy format. Again you can convert into phasor domain, a square plus b square, and tan inverse of b by a you can get in terms of phasor domain. That's it. So from that you can say the total current. Okay, is it clear for everyone so far? Because you do not have a scientific calculator, so there is no option. You can convert like this: r cos theta plus j r sin theta. In that manner you can do it. Okay, so moving on to the next one. If it is clear, moving on to the next one. You see everybody, for the figure, calculate the current is, find the voltage VAB. Where is is? Is is the source current. Okay, if you want to find out this current, you have to calculate I1 and I2. Obviously, I1 is the current which is flowing through R and XL. I2 is the current which is flowing through R2 and XC. Okay, how do you calculate this one? How do you calculate this one? Voltage across this, voltage across this will be same or not? That is equal to supply voltage or not? Because they are connected in parallel. They are connected in parallel. So E divided by R plus JXL, E divided by R2 plus R2 minus JXC, you will get currents. Add up them, you will get total current. Now we want VAB. We want VAB. How do you calculate VAB? See. How do you calculate VAB? If you from the ground, if you move VA, from the ground if you move VB. So calculate VA potential. Voltage across this branch is nothing but supply voltage into this branch resistance divided by total resistance. Voltage division rule. Simply voltage division rule. Similarly, VB, supply voltage into this branch resistance divided by total resistance. So I am going ahead first for this one, I1 I2 calculations. So I1 will be E divided by R1 plus JXL. E is 100 at an angle 0. R1 is 3, JXL is plus J34. So I1 is equal to 3 square plus 4 square, 16 plus 9, it will be 25. Root 25 will be 5, 100 divided by 5, it will be 20. Tan inverse of 4 by 3. So it comes out as around 53.13. So minus 53.13. So the current lags the supply voltage by minus 53.13. Okay, because it is an inductive nature. So that is I1. Similarly, I2. E divided by R2 minus JXC. E is 100 at an angle 0. R2 is how much? R2 is how much? That is 8. 8 minus J6. So 8 square, 6 square. 64 plus 36. You will be getting 100. Root of 100 will be 10. 100 by 10, it will be 10. 10 at an angle 6 by 8. Of course, that is tan inverse of 6 by 8. So I am getting around 36.86. Minus 36.86. If it goes up, then it will be plus 36.86. So this is your I2 current. Now if you add up them, again the same as the previous one. If you add up them, the total source current will be I1 plus I2. That will be 20 at an angle minus 53.13 plus 10 at an angle 36.86. How do you do this one? 20 cos minus 53.13 plus J20 sin 53 minus 53.13. So be careful, do not forget minus sign. Plus another term is 10 cos 36.86 plus J10 sin 36.86. 36.86 will be probably 0.8, I think it's so. Cos of 36.86. Yeah, 0.8. So sine will be 0.6, it will be. So in that way you can do. Again add up these two, you will get the A plus GP format or X plus IY format. Okay, X plus IY format. So take up the magnitude and take up the phase angle. So clear now? So this is clear, I think so, for everyone. Okay, very good, Kalyani. Super. The same way, now take up the voltage magnitudes. So I am going for the voltage magnitudes now. Voltage across this one from the ground, VA. From the ground, if you move like this, you are reaching A terminal. So it will be voltage across A point is nothing but VA. Similarly, voltage across B point, so it will be VB. Okay, because current is traveling from top to bottom. For a positive half cycle, you can take up like that. So VA, voltage division rule. VA is equals to source voltage 100 at an angle 0 into that reactance or that resistance, that is J4 divided by total impedance, that is how much? 3 plus J4. So 100 into 4, it will be 400. 400 at an angle 90 divided by 4 square plus 3 square 5. 5 at an angle tan inverse of 4 by 3. How much we have got? Tan inverse of 4 by 3, it is 36 or no, minus 53.13. So of course plus 53.13 at the denominator. If it goes, it will be minus 53. So you will be getting it as 5 8s of 40, 80. So 90 minus 53.13. I am getting around 36.86. This is VA potential. Now VB potential, how is a VB potential? 100 at an angle 0 into VB. I am calculating across capacitor. So minus JXC minus J6 divided by 8 plus 8, sorry, 8 minus J6. So it will be 600 at an angle minus 90 divided by, it will be 10 at an angle 36.86. Okay, of course, minus 36.86. I missed this point. So it will be 60 at an angle minus 90 plus 36.86. I am getting around 53.13. So these are the voltage across A and B. Now what is VAB? Can you tell me what is VAB? VAB is nothing but simply VA minus VB. VAB is nothing but VA minus VB. Kalyani is saying approximately 100 at an angle 73.74. Let's see. VA minus VB. So that will be 80 at an angle 36.86 minus 60 at an angle minus 53.13. So how to do? Again, how to do? You have to split into, you have to convert into this one rectangular format. 80 cos 36.86 plus j 80 sin 36.86 minus 60 cos minus 53.13 plus j 60 sin minus 53.13. So that is the only option, because if you do not have a scientific calculator, the only option is, best possible option is that one. So you will get A and J term, that is x plus iy format. So let me represent that. 80 cos 36.86, it will be 0.8 plus j. 80 sin 36.86 is 80 into 0.6. Next, minus 60 into cos minus 53.13. This will be minus to the whole. So plus j 60 sin minus 53.13. So you will be getting totally a x plus iy format. Okay. So do that x plus iy format, get the square root of that one, and phase angle. You will get the phase angle difference. Okay. So there is no much difference between DC circuit DC series parallel circuit analysis and AC series parallel circuit. The reason why I am taking is, it will be a practice for you so that you will not commit any mistakes. There is no difference at all. The only thing is you need to include these J terms. You need to include these J terms. Okay. I think it is clear for everybody. So let's move on to the next question. Okay. All right. So let's move on. Look into this question and try to solve. Look into this question and try to have a look at this one. For the networking figure, compute I, calculate I. What is I? I will be obviously I1 plus I2 plus I3. I will be obviously, no doubt, I will be I1 plus I2 plus I3. Find I1, I2. Obviously, you just calculate them and add them. Verify Kirchhoff's current law by showing that I is equals to I1 plus I2 plus I3. So if you wanted to verify, you calculate the total ZT. So impedance, voltage divided by impedance, you will get current. So the total current is equals to E divided by ZT, total impedance. So this current must be equals to sum of these three currents. That is the only thing. Find the total impedance. So that is what he's asking. Okay. So let us calculate. Let us calculate. Let us calculate I1. Let us calculate I2. Let us calculate I3. Okay. Can you tell me what is I1? Can you tell me what is I1? What is I1? All the elements are connected in parallel or not? R1 is in parallel. R1 is directly across the source. This R2 and XL is also across the source. R3, XL, XE. This is also, this entire combination is across the source. So simply I1 is equal to E divided by R1. How much it is? 200 at an angle 0 divided by 10 at an angle 0. So you'll be getting it as 20 at an angle 0. This is I1. Yes or no? I1 will be 20 at an angle 0. Come on, my dear, tell me. I1 will be 20 at an angle 0. That's it, simply 20 amperes. Okay. Now take out I2. Take out I2. I2 is equals to E divided by that path impedance. That is, E is 200 at an angle 0 and impedance is of how much? 3 and J4. That is 3 plus J4. 3 plus J4, 3 square plus 4 square, it will be 25. Root of 25 will be 5. So you will be getting it as 5 4s are 20. Probably it will be 40. 40 at an angle. Tan inverse 4 by 3. You have got it as 53.13. Is it so? 4 by 3. Tan inverse of that. Yeah, 53.13. So it is minus 53.13. Now similarly I3. 200 at an angle 0 divided by what is the impedance of this path? R, that is 8, and here inductive reactance is there, capacitive reactance is there, that is J3 is there and minus J9 is there. So 8 plus J3 minus J9. So it will be of 8 minus J6. That's it. There is a capacitive reactance and inductive reactance. One is negative sign, one is positive sign. You just compensate them, so you will be getting 8 minus J6. Okay. So this path, the third path, that is resistance, inductive reactance and capacitive reactance, that path impedance is going to be 8 minus J6. So 8 square plus 6 square, it will be 64 plus 36, root of 100 will be 10. So 200 divided by 10, it comes out as 20. Tan inverse of 6 by 8. Of course, it is minus 6 by 8. I am getting it as 36.86. So if it goes up, plus 36.86. So these are the currents. These are the currents of each branch. These are the currents of each branch. So add up them, you will get the total current. So how to add? There is no option. How to add? There is no other option instead of converting into R cos theta plus JR sin theta format. Otherwise, you take up the Z1, sorry, total Z impedance. Let us calculate. What is the total impedance? Let us calculate. I want ZT. If three branches are there like R1, R2, R3, so what will be the ZT? R1, R2, RT. What will be the ZT? R1, R2, R3 divided by R1, R2 plus R2, R3 plus R1, R3. Okay. Or otherwise R2, R3. R1, R2 plus R2, R3 plus R1, R3. Like that. Or otherwise you can take up individual branch admittances, which whatever the way you are comfortable, you can take up in that manner. Okay. So let us do. I am going for admittance because it will be having so many J terms in the calculations. I'll show you both. So this is of 10. 3 plus J4 ohms. 8 minus J6 ohms. So ZT is equals to R1, R2, R3. That means what? Z1, Z2, Z3. So 10 into 3 plus J4 into 8 minus J6 divided by, if you have a scientific calculator, you can do it easily. Divided by Z1, Z2. So 10 into 3 plus J4 plus Z1, Z3. 10 into 8 minus J6 plus Z2, Z3, that is 3 plus J4 into 8 minus J6. So this is how it looks like. Or otherwise, another possible option is either you have to multiply all these things, or otherwise one option is better to you go for impedance. Calculate admittance y1, y2, y3. What is y1? Y1 is going to be 1 by 10, so it will be 0.1 mos. What is y2? 1 by 3 plus j4. Here also you need to calculate, obviously. So that is by taking with rationalizing, that is opposite sign. So it will be 3 minus j4 divided by 3 minus j4. So you are going to get it as 3 square plus 4 square. 3 square plus 4 square, it will be 25. Yeah, 25. So 3 by 25 minus j4 by 25 mos. This is y2. Similarly, you can go for y3 also. y3. y3 is going to be 1 by 8 minus j6. So again here also 8 plus j6 divided by 8 plus j6. You just multiply and divide. So 8 square plus 6 square. So it will be 64 plus 36, 100. So it will be 8 by 100 plus j 6 by 100. This will be mos. Like that you are going to get. Now the total admittance will be y1 plus y2 plus y3. Add up them. So y1 is 0.1, y2 is y2 is 3 by 25 minus j 4 by 25. y3 is 8 by 100 plus j 6 by 100. So you will get conductance term, you will get imaginary term. So you can add up easily. So 0.1 plus 3 by 25 plus 8 by 25. 8 by 100 is going to be 0.08. 3 by 25 how much? 0.12 plus 0.01. Sorry, not 0.01. It is 0.08 plus 0.1. I am getting around 0.3. Now 4 by 25 and 6 by 100. 6 by 100 is this minus, plus j 0.06. What is 4 by 25? 0.16. So this is minus j 0.16. This is minus j 0.16. And this is plus j 0.06. So obviously this is greater. So you are going to get it as minus j 0.1. This is total yt. Now you can take up total zt. Total zt is going to be 1 by yt. So 1 by 0.3 minus j 0.1. What is the other option? The only thing is you have to cross multiply. 0.3 plus j 0.1 divided by 0.3 plus j 0.1. Let me hide so that I can show you. So 0.3 square plus 0.1 square. 0.3 square plus 0.1 square. So I am getting around 0.1. So it will be 0.3 divided by 0.1 plus j 0.1 divided by 0.1. Is it so? So you are going to get it as 3 plus j1. Is this the impedance everybody is getting? Anybody tried? Anybody tried? Come on, my dear, respond. 3 plus J1, is it so? Total impedance. Are we getting this one? Somebody try and tell me. Right. Okay. So this is how the procedure you can do. So calculate total impedance and voltage divided by total impedance. You will get the total current now. Now the source current will be E divided by total impedance, or otherwise you can take up E into YT also. In this manner also you can take up. So E is how much? Source voltage, how much we have got? 200 at an angle 0. Total impedance, how much we have got? 3 plus J1. So 200, 3 square plus 1 square, it will be 9 plus root 10. So it will be root 10, na? 200 divided by root 10. I am getting 200 divided by root 10 will be 63.24. At an angle tan inverse of 1 by 3. 18.43 minus 18.43. Is this a total current? Everybody getting 63.24 minus 18.43. When you sum these, you have to get the same. 20 amperes, 40 at an angle minus 53.13, 20 at an angle 36.86. When you sum them, when you phasor sum, you have to get this much value. Are you going to get the same value? Is everybody getting the same value? That is matched. Kalyani, thank you so much. Super. You can check. You can check like that. What is another question is asking? So Kirchhoff's current law is satisfied. I1, I2 are calculated. Total current we have calculated, even impedance also. Okay, that's it. Look into this one. For the network in figure, find the current I, find the voltage VC, find the average power delivered to the network. Average power delivered to the network is nothing but what? E into I into cos phi. E into I into cos phi. How do you do this one? Current I. If you want to find out current I, either you can take up current, this one, phasor sum of currents, or otherwise calculate total impedance, voltage divided by total impedance, that is also fine. Remember here you treat here, not capacitors are not, of course capacitors are connected in parallel, but he has not given capacitor values, not C in terms of farads. It is not given in terms of farads. It is not given in terms of farads. Do not simply try to what I can say. If you have capacitor, you can go ahead with addition of capacitance values, that's C1 plus C2. But we have got already here, what is that? Ohmic values. So it is same as like one resistor, two resistors are connected in parallel. So R1 and R2 divided by R1 plus R2. So it is minus J400 minus J400. It will be minus J400 divided by 2. You will get, definitely you will get it as minus J200. There is no other option. So equivalent paths, the path oppositions are 400 ohms, 400 ohms. So when they are connected in parallel, the path opposition will be reduced. Minus J200, no doubt. Okay, so this side path impedance is 100 minus J200, and this side path impedance is okay, this is J600 and minus J200. So J600 minus J200, so it comes out as J400. J400. Now you can calculate easily I1, you can calculate easily I2. Or otherwise you can take up total impedance. Anything is fine. It is your wish. Whatever the way you are comfortable, you can take up. I think calculation of impedance is very easy. So here you can take up this as Z1. You can take up this as Z2. So Z1 and Z2 are in parallel now. So total Z2 with ZT will be Z1 Z2 divided by Z1 plus Z2. What is Z1? Z1 is going to be J400. Z2 is what? How much? 100 minus J200 divided by Z1 plus Z2. So that is J400 plus 100 minus J200. So please calculate and tell me. Denominator will be, obviously this is going to be 100 plus J200. Numerator plus J40, 40K. Think 400 into 100, it will be 40K. So plus J400 and J into J square minus 1. So minus into minus plus. So plus 200 into 400, it will be 2 4s are 8, 80K. So this is the value. There is a value of ZT. So you can take up, or otherwise you can calculate YT. You can take up. Solve this one. How to solve? How to solve? Take the magnitude, take the phase angle. Take the magnitude and take the phase angle of this numerator and denominator. So you can solve it easily. Come on. Can you tell me what is the magnitude of the numerator? I think 100 you can take common. If you take 100 as common, this will be cancelled. This will be 0 extra. So it will be J400 J plus 800. So even you can take up 400 also outside. So J100 plus 200 divided by 1 plus J2. Or otherwise you can take up any magnitude, you can get this one. Okay. So once you get the total impedance, you can calculate I. I is equals to 100 at an angle 0 divided by the total impedance. Same manner. Okay. Then once you find out this one, you know voltage, you know, can't you calculate voltage division rule? You can calculate voltage division rule. VC is equals to what? VC is equal to total voltage into this reactance. Be careful, this reactance is minus J200. Minus J200 divided by total impedance, that is 100 minus J200. Okay, so the voltage across J400 ohms, that is this XC1 and XC2 both are going to be same. So I am replacing with J200. If you take J400 gone case, okay, J400 divided by 100 minus J400 you cannot write because it is equivalent reactance. You have to replace. Okay. So once you get current, once you get voltage, you take up simply power delivered as voltage 100 into that current into cos of angle between them, voltage and current. Okay, so simple. So this is how you have to do the calculations. Anyhow, so Kalyani is saying around 0.57 at an angle 52.15. Is that the impedance? Might be the numerator, and no, it seems like very larger value. But anyhow, you check. That is a procedure. Oh, you're saying about current? Okay, fine. All right. So that's how you can check and take up this as homework. Find the total impedance. This is a current source, you find the total impedance. So this will be anyhow 2.4 and 2.4. Both are in parallel. So it will be 1.2 kilo. J 1.2 kilo. And this is resistance. I'm so sorry. This is resistance actually. This is 1.2 kilo and 1.8 kilo. You can take up this one. Otherwise, simply use current division rule. Simply use current division rule. Okay, he is asking total impedance, na? Okay, total impedance. So J 1.2 and this one impedance, and for that you have to add. You'll get total impedance. Find voltage V1 in phasor form. What is V1? V1 is here. So if you know current V1 is going to be what? Simply current into resistance. That is 20 milli at an angle 0 into resistance is 1.2 kilo at an angle 0. Kilo milli gets cancelled. So it will be 12 2s are 24. 24 at an angle 0. Find I1. What is I1? Where is I1? I1 is the current which is flowing through capacitor. So you take up one reference and you can take up, you can draw the phasor diagram. Current flowing through capacitor definitely will lead with respect to that voltage, capacitor voltage. Remember that. So V2 phasor is asking, where is V2? V2 is here, voltage across the inductance. Voltage across inductance will be leading with respect to current flowing through that inductance. Okay. So try this one, try this one also. Same current division rule here. Current will be divided here and the same current comes out again 4 milli. Again the current will divide between these two, these three, and the same current comes out 4 milliamperes. Use current division rule, it will be so simple. Okay. Alright. So that's all for the day. So these are some questions on series and parallel AC network. Tomorrow we are going to discuss about the fourth element in the network theory. Along with R, inductor, capacitor, there is one more element so called memristor, memory resistor. It is not mutual inductance, it is memristor. So where we use this memristor, what are the applications and how it works, the function we will see, and applications we will see. I'll be taking around 20 to 30 minutes. That's fine. Tomorrow we will be finishing this one. So with the tomorrow, the basics are done. So my sincere request is try to share, try to go through this one, try to go through the series, because I have taken only very simple questions and I have taken basic questions. Okay, if you have any doubts, you can reach on to my Telegram channel, Naveen Gollapalli. Electrical by Naveen Gollapalli. Or otherwise, if you have any specific doubts related to electric circuits, you can reach out only electric circuits doubts. Electric circuits underscore doubts. You can reach out to the electric circuit. If you have any doubts, you can directly post your questions onto this Telegram channel. Either on this one, if you feel, on this channel, multiple subjects are posted. Okay. If you are feeling uncomfortable, you can come on to the electrical circuits underscore doubts. There you can post out and else only electrical circuit doubts. Likewise, electrical machines underscore doubts also, electrical measurements underscore doubts also is there, so that I can respond very quickly. The subject wise you can discuss if you have any doubts. Okay, so that's all for the day. Thank you so much. Have a nice day. Right, if you have any questions you can ask me. Okay, I think this will help you a lot, I'm damn sure, because here so many questions are there, and here I'm going to create, I'll upload the textbooks and I'll upload daily questions. I'll try to post daily questions. I'll try to post, so you can see textbooks, and I'll upload some material also if possible. Right, thank you. Doubt discussion also we will do this one. Thank you so much. Have a nice day. Bye bye. See you tomorrow at again 12:30.